Okay, hope everybody's doing fine. So we'll enter into our second video here on engine fundamentals. And this picture of an engine block, otherwise known as a cylinder block. These are typically made of cast iron. A lot more nowadays are cast aluminum. For our purposes, we're gonna want to refer to this as the building block. This forms a basic foundation of our engine. Another term that we would use for this is the bottom end. Now there are other components in the block that we'll talk about here in just a bit, but the engine block is the basic foundation of an engine and is referred to as the bottom end. All right, so here's a modified cutout of a four-cylinder block. That big round object there on the left-hand side of that with the notches cut out of it, that's a flywheel. And then you see your crankshaft in there, which we'll look at another here in just a second, but we've got our pistons. So down there is the bottom end, boom, nice arrow. And then this portion up top is going to be the head, or a cylinder head, and this is known as the top end. So this is just a typical four-cylinder engine block, usually used in smaller cars. This one here is the V6 engine block, which is very common in today's automobiles. I mean, even vehicles that used to be 8 cylinders, or the technology has gotten to the point where they can get a lot of power out of a V6 engine nowadays. What do you guys think this might be? Well, we're going to get to that later. That's a timing chain. The larger sprocket on top would be your camshaft sprocket, and the smaller sprocket at the bottom would be our crankshaft sprocket. All right, so here is a little cutout of a four-cylinder engine block. We're basically looking at here, and if you look at the blue components, the block itself, the crankshaft, the pistons, the piston rings, connecting rods, and our oil pan. So first on our list is the block itself. We've already talked about this quite a bit. And then inside, within the block, we've got our crankshaft itself. You see the crankshaft sprocket there in the diagram and the pulley. Over here we have a piston. Now, pistons typically have 3 rings around them. They'll have a primary or first compression ring, and they'll have a secondary or second compression ring, and then the third one down is the oil ring. And then down here we have the connecting rod, and this connects to the piston and connects the piston to the crankshaft. All right, so last but not least, we have the oil pan. Now, the oil pan is where the oil reservoir is. Generally, your oil pump is located inside that as well. So let's move on. All right, so now we're going to get a little more in-depth to the crankshaft, what you need to know. Let me see if I can get a pointer here. Let's see, laser pointer. All right, cool. So this is our crankshaft right here, and this is a crankshaft for a 4-cylinder. If you kind of picture drawing a line from here straight through, all right, that would be the center portion of it. So then you would have a piston connection here, 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 and over here. Okay, so very important. What a crankshaft does is it changes the up and down movement of the pistons into a rotating motion. All right, these guys here are counterweights, and what's important about a counterweight is because all of these offsets, those counterweights are crucial, so that that engine just doesn't vibrate violently and come apart. So it's super important to have those counterweights so that, well, we don't want to be picking up our engine off of the street. So we want to make sure we remember this. Very important. Changes the up and down movement of the pistons into a rotating motion. All right, so this is just a rough draft here of a piston. You've got your top compression ring up here, otherwise known as the first compression ring. The second, or sometimes secondary, would be there. And then you have your oil control ring. I'm not going to test you on knowledge of a wrist pin or a snap ring, but that would be how the piston itself connects to the connecting rod, which I do want you to remember what a connecting rod is. And then this portion here where the bearings are would be what goes around the crankshaft. So, all right. Okay, so this is a better picture of an actual piston. And so, you know, what you need to know is that piston is inside a cylinder, and you know, obviously metal has to have a little bit of space between the piston and the cylinder wall. Otherwise, we got metal scraping on metal, and that's not a good thing. No bueno. We'll talk more about metal on metal when we get into oil, into lubrication. But these rings, these three rings here, they seal up the space in between the piston and the cylinder wall. So obviously, compression rings' main objective is to prevent combustion pressure leaking into the engine crankcase. Remember when we were talking about the four-stroke cycle in the last video, and I said, you know, when the compression stroke and during the power stroke, both valves are closed because we want a sealed combustion chamber. And when we have worn compression rings on a piston, we can often have what's referred to as blow-by, and this is some of that pressure leaking past into the crankcase, and it's essentially a loss of power. So that's term blow-by. We would link that back to worn compression rings. All right, so here again is our first ring, and for simplicity, for our purposes, we're just going to use first ring, second ring, and then over here is our oil ring. Now, if we were in class, I would actually be able to hand these parts out so you guys could physically look at them, and unfortunately, we don't get that, but the oil ring prevents engine oil from going, so just like we don't want the combustion pressure leaking past into the crankcase, we don't want the oil that's in the crankcase entering into the combustion chamber. Otherwise, we're burning oil, and that's no good either. So, all right, let's move on. Okay, so you guys don't know it, but I had to take a quick break and let the dogs outside for a second. So, all right, got my laser pointer back. All right, so moving on to the cylinder heads. Um, the cylinder heads essentially sit on top. There we go. Sits on top of the engine block. If you think back to that picture, oh goodness, way back, the flat portion on top of the engine block, why the head sits on there. In the heads, and again, we're going to be simple. There's a lot more going on than what we're going to be able to cover, but our valves are located in there. Our camshaft, if we have a overhead cam engine, otherwise can be known as a SOHC, single overhead cam engine, or a DOHC, dual overhead cam engine, and we'll get into that some more here in a bit too. So, and other related components, when we talk about the valve train, I'll be able to elaborate on that a whole lot more. Now, we refer to the engine block as the bottom end. What do you guys think we'd refer to the cylinder head? Yes, you are right. We refer to that as the top end. So we've got the bottom end and the top end. And let's go to our next slide and the cylinder head. Now, this is underneath. This is the portion that bolts to the deck of the block. So you can see these would be bolt holes here. These other little passages, and we'll talk about that some more, are water jackets and oil passages for oil and water or coolant to flow through the engine to help cool it. So this encloses the top of the cylinders with the combustion chamber. Now, point out on this, each cylinder, so one cylinder is going to be right here and so on down the line like that. And this particular head has two valves. They always have a minimum of two valves. You're going to have an intake valve and an exhaust valve. You notice though, these valves are not the same size. So which one do you think is bigger? And there are only two answers. It can either be the intake valve or the exhaust valve. And since I can't ask that question of you in person, I'm just going to have to give you the answer. And that answer is the intake valve is the larger one. So this would be intake valve, this would be exhaust valve, and so on down the line. And we'll talk a little bit more about that. This is where the air-fuel mixture gets compressed and ignited. The ports, these valves would actually be able to come out, but where they sit is cast into the head itself. So there's a nice little green circle for you. Just remember this, when we talk about valves, the intake valve is the bigger of the two. Okay, so we're going to talk about the valve train, and get my pointer here. Okay, this is an illustration of an overhead valve engine, and I mean, everything that we know today is overhead valve. The valves are up here on the top, overhead, and that's going to be the same whether it's called an overhead valve engine or an overhead cam engine. The difference between overhead valve and overhead cam is where the camshaft is located. All right. So in an overhead valve system, as we see here, the camshaft is located down in the block. Overhead cam, and we'll have an illustration of that here in a bit. The camshafts would be up higher up top here. So, but for this slide, we're looking at what consists of the valve trains, and essentially it's everything that works in conjunction to open and close the valves. So obviously you're going to have your camshaft, and we'll talk about the camshaft a little bit more a little bit later. In this illustration, you don't see lifters, but in an overhead valve scenario, you would. Here's your push rods. All right, and then you've got your rocker arms, because as this rod goes up and down, that moves that up and down and moves this up and down. And then you've got your spring, your valve assembly's got your spring and your valve in it. So an overhead cam engine could have everything you see here, except it wouldn't have push rods. So overhead cam system is not going to have push rods. Okay, so I don't have any pretty little illustrations on this one, but the valve train, as I said in the last slide or portion of the video, it opens and closes the valves at the correct time. And that's essentially where we get the terminology of timing on an engine. Your camshaft, and I wish I could send one around the classroom so everybody could see it, but it has these little lobes, and they're egg-shaped lobes on the camshaft, and what they do is they open each valve. The camshaft can be located in the engine block if it's an overhead valve like I talked about, or it'd be in the cylinder head if it's a single overhead cam or a dual overhead cam. And again, cam-shaped lobes or cam lobes are egg-shaped protrusions machined on the camshaft. The one lobe is provided for each valve in the cylinder head. So, and if you have a dual overhead cam, you're going to have an intake cam and an exhaust cam. But we'll talk about that a little bit more later as well. All right, now we got a nice little illustration in motion. So this is an overhead valve engine. So you'll notice here's our crankshaft. Our camshaft is down below, which would be in the block. You've got your timing chain or belt. Notice again, the crankshaft sprocket is smaller than the camshaft sprocket, and that's because the camshaft is going to turn at half of the speed as the crankshaft. So if the crankshaft it turns 10 times, that camshaft is only going to have turned 5 times. So these are the lifters that weren't in the last illustration, but you can see they help in pushing up on the the push rods, and then you can see your rockers, how they're working. Now in overhead cam engine, if it were a single overhead cam on like a 4-cylinder, you may, and it had more than just 2 valves per cylinder. If you had 2 intake and 2 exhaust, you may still see rockers in that type of scenario. Okay, so here's just a static view of overhead cam. Your camshaft is up here, all right, and this still uses the use of a rocker, and that pushes down. An overhead valve, the camshaft is down here. You can see there's a lot more involved in an overhead valve system than in an overhead cam system. They do still use them in certain applications. More common when I was your age than now, but nonetheless. All right, so we just have a few more slides through on this video, but here's a rudimentary illustration of a single overhead cam engine. Now this is a 4-cylinder, so a 4-cylinder would only have 1 head. Okay, and we'll talk more about this as we continue on in our learning. but whether it's single overhead cam or dual overhead cam is based on the number of heads that an engine has, not the number of cams it has. I know that doesn't sound correct to you now, but it will as we move forward. So you see here your cams on top. Notice the camshaft pulley is larger than the crankshaft pulley. And these would be the egg-shaped lobes that push the valves open, and then the springs close the valves after they've been opened. Here's a non-moving picture of a dual overhead cam. So this is still a 4-cylinder engine, but now you'll notice each cylinder has 4 valves instead of 2. It's still only going to have intake and exhaust, but in this case, you've got 2 intake valves and 2 exhaust valves for each cylinder. So one of these is going to be, here you've got your intake crankshaft, so all of these valves on this side are intake valves, and then all of the valves on this side are exhaust valves. So 4-cylinder engine is going to have 1 head. So if it has a single overhead cam, it would have 1 cam. If it had dual overhead cam, it will have 2. Now that changes when we get into a V6 and a V8. All right, so this is actually the last slide in this 22-minute long video that I've had so far. Can't believe that. But here you've got dual overhead cam engine in motion. And so you'll notice that since I have an intake camshaft and an exhaust camshaft, both intake valves, so let's say this side is our intake, for each piston, the intake valves open at the same time. So if you have 2 valves for each cylinder, that'd just be intake and exhaust. If you had 4, you would have 2 intake and 2 exhaust, just allowing for more fuel air mixture to get in so we can have bigger bang. So there we are. I hope you guys are doing very well, and we'll have a little quiz over some engine components, and then we'll move on.